Hi, my name is Hamza and welcome to my project presentation in the subject of data mining and statistical learning. Excessive alcohol consumption can have adverse impact on a person's mental health and physical well-being. While the impact may vary from one person to another, yet the excessive consumption can dramatically impact a person's cognitive abilities from a pure medicinal standpoint. This project aims to study the effects of alcohol on the academic performance of the students. It must be noted, however, that the feature space is not just limited to the alcohol-related variables, but there are other variables also involved from the socio-demographic space, such as the age, gender, etc. The dataset can be obtained from Kaggle from the given link. There are two datasets provided, one for each of the maths and Portuguese classes. These include various attributes related to the demographic, social, and academic areas. The original dataset is structured into 30 plus 3 columns, that is, a total of 33 social, demographic, and academic attributes, which are a mix of categorical and numerical data types. The last three columns, the G1, G2, and G3 columns, correspond to students' grades or performance under the given period. These variables include student school, student's home address, parents' cohabitation status, etc. For the scope of this project, an augmented label called G3X will replace G3, which essentially identifies whether a student is higher or lower than the mean score of the final period for grade G3. Next up, I'll showcase some visuals from the exploratory data analysis. Here's a look at some of the EDA during the preliminary exploration. To the left is a fairly symmetric histogram for the continuous response G3, however with a slight tail to the left in the region of 0 grades perhaps. Then we have the G3 study across the various predictors across the feature space. Some of the features that are relatively more indicative of the grades here appear to be the school of study, willingness to pursue higher education, daily alcohol consumption, past failures, mother's education, etc. On the other hand, factors such as gender, romantic relationship, and alcohol consumption on the weekends are not as strong in this regard. Here are two views on the correlation situation between the non-categorical features. On the left, notice the unmistakable correlation between various grade scores, that is in the green box. This observation follows quite intuitively since a student's performance, better or worse, would generally be similar across the various grading periods. More about this later. To the right is another view, but with predictors ordered by their level of correlation. More interesting observation here, looking at the purple box, we observe that the predictor go out, which is going out with friends, weekend alcohol consumption, free time, and daily alcohol consumption show apparent correlation. The blue box, which is a group of negative correlations, gives some insight as to how failures in the past are a bit of negative proxy for students' grades. It would be fair to say that both the phenomena appear rather natural and that a correlation matrix would further corroborate it. Let's now touch upon the ideas and methods at the heart of this project. Predicting academic performance G3X on basis of the Portuguese dataset purely, predicting academic performance on the maths dataset on the basis of models trained with only the Portuguese dataset, tests the hypothesis that alcohol has a direct bearing on academic performance, and then additional insights as to the relationship between alcohol and certain other socio-demographic data. Here are the main methods implemented for the following objectives. For the prediction of academic performance, I tested with regression and classification techniques such as logistic regression, random forest, boosting, generalized additive model with splines, etc. For the testing of whether alcohol has a direct bearing on academic performance, I utilized ANOVA or analysis of variance, two key HST or honestly significant difference, and then for further insights as to whether alcohol and certain other socio-demographic variables are related, I conducted various graphical tests. Prior to any modeling, all the categorical variables were factorized as the foremost step. Then assuming from the correlation analysis where we saw how greatly the G1 and G2 grades are correlated with the response variable, that is G3X, we know that both of them are highly correlated, and so we need to subject them to the variance inflation test. That is a scientific way to ascertain their exclusion from the dataset rather than just outrightly removing them from the feature space on the basis of apparent bias. This phase of analysis is concluded with the removal of G1 and G2 attributes from the feature space as evident from the multicollinearity and the VIF data inspector above. This slide shows a bit about the train and test efforts based entirely on the Portuguese dataset, which was split 80-20 for the test and train subsets. This slide showcases some of the tuning efforts for a couple of methods used. The next step I took was to upscale the task of prediction by carrying out prediction experiments on the maths dataset while utilizing the models trained entirely on the Portuguese data. What makes this challenging is that, unlike Portuguese, the grade data of maths has understandably a different average score, and so the indicator functions yield a different response local to the maths data. Being able to predict the maths grade on basis of Portuguese models is hence a tougher job. Here I tested various models including logistic regression, generalized additive models with spline, random forests, etc. There are some goodness of fit tests and analytics conducted that are available on the next slide. Here are some visual analytics from the goodness of fit tests I conducted for the logistic regression. On the top are the normal QQ plot and histogram of standard residuals prior to the removal of outliers. On the bottom are the same graphs but after the removal of outliers using Cook's distance. We can see better alignment as well as more symmetry in the second graphs. I carried out some additional experiments to see if we can employ response transformation using Boxbox. However, an approximate value of 0.8 was found for the lambda, which is rather close to 1 and maybe not requiring any explicit transformation. I still, however, experimented with square root and log transformations, but those didn't improve upon the predictive performance. Also carried out principal component analysis or PCA, which as an overhead required me to convert all the data to numerical. So I proceeded to create dummy variables and the data set inflated to approximately 40 variables in the feature space. With that, I carried out the PC analysis and observed that it required 33 predictors to cover 95% variance in the data. The results, however, were suboptimal for adoption. Moving to the next objective, I want to test the hypothesis as to whether alcohol consumption had a direct bearing on the student's performance or grades. For that purpose, ANOVA and Tukey HST methods were used. Analysis of variance test was conducted on the daily alcohol consumption as well as the weekend alcohol consumption. Both the variable range from the lowest value of 1, which I established to be the control group for this experiment. The values of 2 were considered as low and anything above as high consumption. The null hypothesis here, or H naught, is that all groups have equal means, that is, none of the groups contribute to low grades or different grades, and the alternate hypothesis, or H1, is that at least one of the groups will have a different mean, or that is to say, a different grade range. Tukey HST is where we'll observe the 95% confidence interval and look for either purely positive or purely negative intervals to draw inferences. Now we'll move to the results section and conclude this presentation subsequently. Test error performances for the various methods is presented here. In the first case, where the train and test data comes split from the Portuguese dataset, we see that the boosting method yields the best performance, albeit at the cost of the tuning overhead. In the second case, where the models are trained and obtained entirely using Portuguese data but tested on the maths data, random forest takes the lead in performance. Here are some visuals from the random forest method. The best MTRY parameter turned out to be 5 in case of the Portuguese testing and had the lowest out of bag error of 26.2%. Since it's a classification task, shown here are the importance results by type is equal to 2, that is for mean decrease Gini. The results are truncated to show up the top ones only. Our initial exploratory data analysis could be revisited at this stage, which should also corroborate the importance to a reasonable extent. Here is a visual for the relative influence from boosting, which can be thought of as an analogous to the random forest's importance. Examining here now the weekend alcohol consumption, on the top snapshot we see the ANOVA results have a very low p-value, which helps reject the null hypothesis here of equal means, or in other words, there is at least one group which has different mean. Secondly, we look into the pure positive or negative intervals from the Tukey HSD output. High control has a pure negative interval which confirms that a group which consumes high levels of alcohol has lower grades than the control group in general. Low-high has a pure positive interval which confirms that a group which consumes low levels of alcohol has relatively better grades than the group which consumes high levels of alcohol. We now look into the ANOVA and Tukey HSD outputs for the daily alcohol consumption. The top snippet above has once again a very low p-value which helps reject the null hypothesis of equal means, or in other words, there is at least one group which has a different mean. Secondly, once again we look into the pure positive or negative intervals from the Tukey HSD output. High control has once again a pure negative interval which confirms that a group which consumes high levels of alcohol has lower grades than the control group in general, which was the case with weekend alcohol consumption as well. Low control also has a pure negative interval in case of daily alcohol consumption, which confirms that the group which even consumes low level of alcohol has lower grades than the control group in general. This is also confirmed by the box plot shown to the right. Here are some additional insights, but this time looking at the weekend and daily alcohol consumption in context of other socio-demographic variables. Some highlights to summarize here is that the weekend alcohol consumption seems to be low for when family support exists and or the quality of the family relationship is high. Whereas for the case of daily alcohol consumption, it is low for when the mother and or father works in the health sector. Here are some conclusions to summarize this effort. The socio-demographic factors, including alcohol usage, can reasonably help gauge the student's academic performance for a given subject. The same models can be employed to test on a different subject as well, although at the expense of some accuracy. Alcohol does have a direct bearing on one's academic performance in general. Alcohol trends with other socio-demographic features are rather insightful but demand additional study to better determine correlation versus causation. And finally, larger datasets could help increase the confidence of testing and inevitably the study conclusions made. Thank you.